going to start with is kind of creating our 5 basic truth tables based on the symbols and the words that we learned yesterday, the different types of things we can do to a phrase or to a statement. So the first one is starting with P, then what would not P be? So we start by saying if P is true or P is false. Those are the 2 options. It can either be true or it can be false. There's no gray area in truth tables. So then not P is the negation of it, or the opposite of it, so that would make a true become false and a false become true.
Okay.
If I have a statement that's true, and I negate it, it is now false.
Oh. Okay. Makes sense.
So then for the next one, when we're considering, what did the downward V mean?
Okay. Or.
So when we have more than one letter that we're working with, what we do, kind of our standard order, is to say P could be true with Q being true or Q being false. Or P could be false with Q being true or false. So P gets 2 turns of being true and then 2 turns of being false. Q gets 2 turns of being true and false, but we line them up in order so that we have every possible combination of true and falses there. Okay. And it's that same order every time, that P is true, true, false, false, and Q is true, false, true, false. Every time, that's how we set up that order. Now, or in a logical statement means that one of them or the other one or both are true. So for the first one, they're both true, that's a good thing. So that's true. For the second one, P is true, and that's okay, because it's or. So as long as at least one of them is true, this is a good thing. And the third one, Q is true, so that's a good thing. And the last one, neither one is true, so that doesn't work.
This really is logical.
It is really logical.
So if it has a true in it, it's going to be true.
For an or.
For an or.
So for an and, we're going to set up our first columns the same way. That's kind of our standard starting place. And means that they both have to be true. Okay? And is not one or the other, and is both must work. So that works if P and Q are true, and it doesn't work in any other case. Start out setting it up the same way. Now a conditional statement in one direction, so this is an arrow pointing in one direction, says that if P is true, then Q should also be true. If P is false, we don't necessarily know anything about Q. Okay? So in words, I could say something like, if it's sunny, then I'm going to go to art prize. So if it's sunny, I definitely have to go to art prize if this is going to be a true statement. Okay? But if it's not sunny, I don't know whether or not I'm going to go to art prize. Maybe I'll go anyway. Right? So in a conditional statement, if the first part is true, the second part has to be true for it to work out. If the first part is false, we don't necessarily have any information there. So what we say about this truth table then is if P is Q, Q is true, that's a true statement. That worked. If P is true and Q is false, somebody was telling a lie. Because if I said something like, if it's sunny, then I'm going to art prize, and it's sunny and I'm not at art prize, I told a lie, right? So that doesn't work. And for the last two, since the premise is false, we call this statement true because maybe it actually worked and maybe it didn't work. So I didn't necessarily tell a lie in those situations, because if I said, if it's sunny, then I'll go to art prize. If it's not sunny, maybe I'll go, maybe I won't go. So that could end up to still be a true statement. So we call those true. This is, I think, the trickiest one. And wrapping our heads around that. So a true first part and a true second part is true. A false first part, you're telling maybe a truth, maybe not, since we don't really know. We didn't give that condition. So those are true. But if the first part's true and the second part is false, that person's telling a lie. On a biconditional, we set it up the same way. Biconditional, the arrows have to work both ways. So the true P should make a true Q. That's true. On the next one, if we look at our arrow going forward, true, false, that's a problem, just like it was on the last one. On the next one, the arrow going forward wouldn't be a problem because that's like the previous table, but this arrow is pointing both ways. So true, false, that is a problem going backwards, so that statement's false. And then false, false, that's okay. So those are our 5 basic truth tables. And then what we can do is start to kind of combine ideas together. And that's where the rest of our problems are. Any questions on those 5 tables? Okay, so then to make a table, if we're told to construct a truth table in this example for not Q and P, that's how we read that. The tilde says not, so not Q, pointing up is and, so not Q and P. What I do is I make a column for P and a column for Q. Those are just our 2 starting premises, and we set it up the same way that we did all those other ones. True, true, false, false, and true, false, true, false. Then, I want to make columns for each of the parts of this phrase that we're trying to prove. So I'm going to say not P, that's going to get a column. And, oops, I always put the little thing in there because I say and so then I write an A. And gets a column. Q gets a column. Now the order we fill these out matters. So the first thing I'm going to do is fill in the not P. So not P is a negation that takes everything and just makes it backwards. So false, false, true, true. Q is Q, so you can just copy over that one, and that's the next thing that we do.
Wait. If you negate true, wouldn't it be false?
Yes.
So the second one should be true, 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 false.
I'm negating just P. So I'm looking at just the P column, and is that, yeah, false, false, true, true.
Because this is false if it's true. And
Because that's just focusing on negating P. I'm not thinking about Q at all there. And then I fill out the Q one exactly the same because it's just Q all over again. Then we want to fill out the AND column. The AND column says that both have to be true for it to be true. That's what AND means. Both must be happening. So the first line, that doesn't work. The second line, doesn't work. The third one, they're both true. The last line doesn't work. And that last column that we filled in is our answer for this statement.
Wait, what are we looking at for and?
Wait.
Are we looking at the whole entire left side and the right side?
For and, we're looking at the 2 things that I filled in green.
Oh.
So are those true? Not the blue anymore. The blue we just set up to get the green stuff.
So it's just
And
what's
then
around
we
it.
like, yeah.
we only look at these.
Yeah.
I was so, because I was looking at the P and the T and I was like, what the, or the P and the Q.
Yeah, no, we just set up those 2 originals to create kind of each piece that we did in green, and then we look at the green ones to create our final answer, the red one.
So you have to make sure that the first part on the one side of the grid or whatever is the first column because it relates the same way as the columns in the.
Yeah.
False.
Yeah, so you have to, like, the original P and Q, make sure different people could do them in different orders, I suppose, and it would still work fine. This is kind of our standard order. This is the order that kind of, I think everybody does it. But please do them in this order because, like, when I read out answers, that's the order I'm going to read the answers. Like, if I was reading this as a homework answer question, I would read this answer as false, false, true, false. So if you set your table up different, Your answer could still be right, but stuff's just going to be shuffled around. So make sure to set it up in this order.
Can you explain to me why you got the 2 truths and the swiggle P? I don't understand.
How I got the squiggle P?
Yeah, can you just go through?
Okay, so these first 2 columns, we're setting up the same way we just set up the first 2 columns in all the first ones. That's like our standard. Then the squiggle P means not P, or the opposite of P. So I'm looking at P and just switching it all out.
You're just looking at P.
Just P, because it's not P.
I was looking at the box and I could not. I was looking at both.
Yeah.
And I was like, what? Okay, just got it.
Just.
And then this one just goes to that.
No.
Do you know why?
I don't.
Maybe somebody really didn't like.
There's a lot of people that don't, but that still seems like an extreme reaction to me.
Frustration.
Alright, so for our next table, we need our 2 premises, P and Q. And we set up the standard order. And then we write out the statement, each little piece of it getting its own column.
Oh, I was looking at the wrong one.
Okay, so we just start with P and Q, the 2 parts of the premise, and fill out the basic order on those. Then we write the thing that we're trying to create the truth table for, each piece getting its own thing. The parentheses are going to give us some kind of order of operations things here, what we want to do first. So just like in arithmetic or algebra, order of operations says we have to start inside the parentheses, we're going to have to start inside our parentheses here. So the first thing I want to do then is fill in the column that says P. Put like a little 1 there, so we can remember we did that thing first. That was the first thing I wanted to fill in because it's the first thing inside of the parentheses. Then I want to get anything else with a letter taken care of, so also still inside the parentheses, I want to take care of the not Q. Not Q means the opposite of Q. So just looking at the Q column, switch them all out. Questions on that?
Oh, dang.
Still working inside the parentheses for order of operations, the next thing that we would do would be the then, the if-then. And so for if-then, remember we said true must result in true. So this first one is false. The next one, true, true, that's good. But a first premise of false still creates a true statement.
What is the arrow thing? Wait.
The arrow is the if-then, so it's the 4th table up above, where a true that results in false is no good. That's somebody telling a lie.
Oh.
A true that results in true is good.
Okay.
A false premise could work, so that still gets a true.
And you like the thing that's in the middle, you just do 2 outside things.
Just the 2 outside things, yep. And now the final step is to do that last little squiggle, the last little tilde or negation. And what we're negating here is the last thing that we did. We're negating that, that if-then part. Negating just makes them all opposites. True,
Is that the answer then?
false,
So 2,
false, false, and that's our answer.
4 looks at 3.
Oh.
Negating just back.
Oh my word. How come you outlined the false
It's a little bit.
Does it matter that you, outlined it in red?
That's the answer. That very last thing that we filled in is our answer. So like when we read off homework answers, I would say the answer for this problem is true, false, false, false.
Okay.
So you write PQ every single time.
Yes. Yeah. Okay, I want to skip that next one, the next little row of examples there. Those bring in a third letter. We'll come back to that, but actually probably not today, probably tomorrow. So we're going to go down to deciding if two statements are equivalent, the last one here on this page.
I have a question before
Yeah.
you move on. If, like, what's in the parentheses is a repeat of a P and a Q, do you have to rewrite them?
If it was just a P and a Q, probably not, but there's probably something else in there, like an and
Right, like the and
or something. So you don't have to, and that's where some people write these things differently. I guess I err on the side of kind of writing everything
Yeah.
instead of trying to leave things out because then I can't always remember what I'm referencing. So I guess I kind of err on the side of writing a lot.
Alright. Did you say one back?
So we're going to go down to this last one. This last one has really two different problems. It says determine if the two are equivalent. They will be equivalent if that final answer, the column that I've been tracing out in red, if that is the same, then the two statements are equivalent to each other.
Wait,
So-
can you say that again?
Yep, so that final answer column that I've been highlighting in red, we'll want to look at those and see if they exactly match. And if they do, that means that these two
Well, so you're
statements
making
are
two of them.
logically equivalent to each
So the
other.
last thing you do,
So are we
For both.
making two different
which are
charts?
Yes.
the carrot thing is.
Well, on the first one, the last thing is going to be that outside tilde, is the order. So for the first one, I do my P and Q.
Are we making two different charts then?
Yes.
Okay.
And the first one is not P or not Q. And I'm not going to do anything with that other one right now. We'll go back and do that table. But first, I just want to focus on one table at a time. So order of operations, first thing I would want to do inside the parentheses is the P. So I just copy over the P columns. Then I would want to do the other letter, not Q, which is going to switch all of the Q's. Then I want to do the or. So remember, or means if at least one of them is true, that's a good thing. So we get true, true, false, true on that. Or is at least one of them is true is good enough.
This one you look at.
This one or this, both is good too. So we need at least one true for an or statement to work.
That's the only column you look at.
And then the final thing we do is that last negation, which is the opposite of the very last thing we did. So we get false, false, true, false. And that's our answer.
What is that?
And then we want to create a table now for the other statement. You can rewrite the P and Q again if you want, or you can just kind of extend this table and say I'm still going to reference back to the original P and Q, which I'm all about writing as much as I need, but I'm also kind of lazy. So if I don't have to keep on rewriting P's and Q's, I
Oh
don't.
my gosh, they're the same. Oh.
So then I go not P
Shoot.
and Q. So now we're going to do that second phrase that's in there, the not P and Q.
The and would be the carrot thing,
Yes. The and is the mountain.
but you don't have to make it sharp.
We will make, that'll be actually be our final answer. It's going to be that and.
Oh, okay.
So not P is going to be the first thing that we do here. So that'll give us false, false, true, true. Then we'll do the Q. Q just copies over the original Q. And then this is the last thing we have to fill out for this one, so this is going to be our answer. And means they both have to be true to get a true.
I like this.
So I get false, false, true, false.
How do you compare the two of them then? Or like,
So then to decide if these two statements are equivalent, we want to look at the two things boxed in red, and if they exactly match, the two statements are logically equivalent. If there's any difference in them, then they are not logically equivalent. So both of those red columns perfectly match, so these two statements are equivalent.
so it's like
Yes.
sentences.
So it's like
by
makes sense.
accident. This is kind of cool. I
I
actually
like
like
It takes some practicing because it is weird,
It is weird, but it's actually like
But-
it's extremely interesting.
but I like it.
I do.
Number 5?
You don't have to use a calculator.
It's,
Pretty great.
No, it's not.
Yeah.
it is.
Oh, no, zero.
No, it's,
This is lesson 2.
there's a thing in.
Can we start on homework?
Yeah, well, there's.
Oh, yeah, you're right.
All right.
You guys are-
So we'll do this one more, and then we'll be done for today. So this first one is a killer. There's lots of stuff in here. So it's gonna be a biggie. So P and Q to start with.
What are we doing?
Whoa.
The first example on the top of the next page.
Ooh.
We're skipping
those.
Yep. We're gonna skip those other ones that have the R's in them for now. Okay. So I start out with my original P and Q, and then I want to rewrite this first statement, giving kind of each thing its own column. If a not is right with a letter, we don't separate that.
What do you start
Ooh,
with?
okay, so there's a lot of stuff here.
It's like, can you give me a minute?
Yep. So when you're trying to decide what to start with, look at parentheses. So just like in algebra and arithmetic, parentheses tell us what we're supposed to do first. Parentheses tell us what we're supposed to do first here. So I've got parentheses around that P, V, not Q. That means I'm going to start with that P, and I'm going to ignore that little tilde that's in the front of this thing. So I'm going to copy over the P, and I'm going to, do not Q next. Okay, so inside of the parentheses, we need to get all of our letter stuff done, and then we need to get the or done. The or is at least one is true, then it's true. Okay, so we worked inside of parentheses. So now order of operations, a not happens before anything else. So I'm not going to do the and next. I'm going to do that little not that's in the front. Okay? Any big operators like an and or an or an if or a then, those things take precedence over the not. So we do the not first here. If the not should be the very last thing that we do, then there would have been big parentheses in the problem like this. That would tell us the not's the very last thing.
How do we know what the not goes after? Like what it compares itself to?
It's going to compare itself to the last thing we did.
Oh,
So it's going to compare itself to the or column.
okay.
So this one compares itself to the or column here. And we're going to not those. So I get false, false, true, false. Now we have another set of parentheses. So we're going to do P, we just copy over the P. And Q, just copy over the Q. And then we're going to do the or for that. Questions on that? We only have one thing left, so this is our answer. And the question is, what is it comparing? It's an and, so we're going to follow our and rule, which means they both have to be true, but what are the both? What are the two things I'm looking at?
The
The
ors.
The last thing that we did, this one, and what other one?
Opposite one. Whatever the things. It's quickly.
The last thing we did in the first one. Okay, so the last thing we did in the first group and the last thing we did in the second group. And that's what we want to compare.
That's what we did.
So we're comparing these two things.
That is what we did.
And it's an and, which means both must be true for true. So I get false, false, true, false. So that's our answer for that table.
This one.
That was, I think, about as complex as they can get with only having 2 letters in them. I mean, there was a lot of stuff going on in that one.
I have a question. What if, like, the second, does it matter? Okay. So, like, in the homework, the second one of the problems has the whole first part in parentheses, and then, like, the arrow in P. Does it matter that P is supposed to be technically before, or is it not?
No, P can come anywhere in it.
So, like, then you would take the answer that you get from the parentheses, comparing to the P, and the P
Yes.
stays in the second column.
Yes.
Okay. Got it. I understand.
So then for the next one, I don't rewrite again my 2 starting columns, so I just rewrite our phrase. So P or P and Q. Parentheses wise, we've got parentheses around those last 3 things. So that means the first thing I'm going to do is the P. Just copies it over.
We learned how to get R.
Second thing I'm going to do is the Q. And then I'm going to do the and. And says they both have to be true to make it true. And then I'm going to do that lonely P in the front. And then the last thing I have to do is the or, and that's going to compare my 2 last answers. So that P, which was all by itself, and the and from the other groups. Or means at least one is good. So I get true, true, false, false.
Wait, are you comparing the or and the P?
I'm comparing the and the P.
So why would the third one be false?
As a man.
Read the and the P to the or.
The and the P
Wait, why
to
would
the or.
why would
Okay, okay, I
the
get it.
third one on 5 be true?
Because it's an or, and for an or I need at least one of them to be true. And I'm comparing the column number 4F and column number 3 is F.
I have to have at least one true.
I have to have at least one true to make it work.
So it's true.
So I got true, true, false, false there. Compare that to the other one, which was false, false, true, false, and those are different. So those 2 statements are not equivalent.
Wait, why is it true, true, false?
So column 5 compares column 3 and 4 and needs at least one of them to be true. So that happens on the first row and on the second row, but the bottom ones have all falses. Okay?
That's the last one we're gonna do.
That's the last one we're going to do today. So that means tomorrow we'll talk about the 2 that we skipped on the front that bring R's into it. That makes for a bigger table. And then we'll talk about this last problem as well, which gives us some special types of tables. So I'm not going to have any homework due tomorrow because this is all collected in one. But if you want to get a jump start on it so you don't have to do it all tomorrow night then, you can do so far anything that doesn't have an R in it. So if you look through the problems and they only have P's and Q's, then you can do them, which means that you can really do 8 out of your 10 homework problems. So if you want to get a good jump start, depending on what night of your week is going to be a busier night, tonight or tomorrow, you can do most of your homework tonight, but we're not going to grade any of it tomorrow.